Thank you for having me. I'm Keiko from Climate Engine. I'm the Director of Product Development. And here I'm happy to talk about the work we are doing and also a little bit about the company first. So we are very much scientist-led company. We started back in 2014 and with support from Google. And then more recently, we became a commercial entity and we became a partner with Google as well. So they are some of the key people from the company. The Justin Huntington, he's a professor from Desert Research Institute. He started the Climate Engine, and the CEO is Jamie Herring. If maybe you know the Habitat 7, which is another company he established, and I have joined the company last year. So this is a more detailed history of the company. So the beginning goes back to 2014, and early clients are Nomura and USGS, mostly the public sector clients. But after we became a commercial entity, our clients include banks such as Bank of Montreal or retail sector clients like SC Johnson. And subsequently, as I mentioned, we became an official Google Marketplace partner. So this is the sort of platform that we are providing to the users. So the key point about Climate Engine is we are building on top of Google Earth Engine. And so we have access to all the data set ingested in Google Earth Engine. And in addition to that, we ingest our own data set and other publicly available data set to our cloud. So there's tremendous amount of data available through us. And then we use Google Cloud and Earth Engine to process and apply algorithms to derive what we are looking for. And then we have our API to provide and export the output to clients. So the biggest advantage here is that it doesn't matter what kind of platform you are using. As a user, you can be using Esri or your own UI or different types of dashboard. We can provide data to any of these through API. So Climate Engine's mission was really initially the code-free solution, that we will do all the heavy lifting of data ingestion and coding so you can just make use of the final data and make action and decision-making based on it. So this is, as I mentioned, we are cloud-based. So that's really the big advantage using satellite images. I think earlier speakers mentioned about data cube. These are certainly requirement for using satellite images these days. And combined with machine learning, which is very data hungry, it's really a perfect combination to derive actionable insight from satellite images. So I also wanted to show you some of the use cases from the public sector. Well, NOAA, National Oceanic and Atmospheric Administration, their drought.gov is powered by Climate Engine. We ingest the initial NetCDF data and we process them, and then it's basically updated daily in that visualization. And also another client is USGS, US Geological Survey, and we supported their restoration project, and they use Climate Engine to process remote sensing and climate data, and also for visualization and data dissemination as well. We also invested ourselves on this technique to identify irrigated area versus non-irrigated area. This had a client Bureau of Reclamation, but this is particularly important for areas that are suffering from the drought, and droughts becoming prevalent and more frequent, and the water availability and rights are becoming really the center of the discussion. Another example is this drought severity evaluation tool we created for the Navajo Nation. So Navajo Nation is the largest First Nation tribe in the United States, and their area is so large, there are many microclimate within. So when the droughts hits the nation, the impact really varies, depends on where you are. So when they distribute emergency funding, for example, you cannot really distribute equal amount to every area. But with this severity tool, they basically use this tool to allocate proportionately to the areas that are affected by droughts. You can use more different uses for this. We created this with NASA, and there are YouTube videos available on how to use this severity tool, which anyone can take a look at. For the interest of time, I'm going to skip some of the slides. We have a variety of products, but the key message here is we are very much on applied science and code-free solution. Having said that, clients like NOAA and USGS, they are remote sensing scientists. For them, we can provide the power of cloud and also power of processing these data to them. But also our main focus after the commercialization has become more of a providing data that anyone can understand, whether you are remote sensing scientist or accountant or consumer. You want to basically see the data or visualization of the data and understand what's going on. So for the private sector client like IHS market, we did analysis on droughts and in the linkage to political unrest for several countries as case studies. For financial sectors, we provide physical climate risks such as hurricanes, earthquakes, and wildfire risks. And again, the point is to provide the data that they can immediately use. So this comes in different ways. One is sometimes they just want indices 0 to 5, or other indices they are already using have a different scale. It doesn't matter, we can adjust that to their need. But also the barrier to remote sensing data has been really the format, like raster data that we use. Google's BigQuery is really changing that area. And we also created our own technology to convert raster to vector in a more efficient way. So what it does is that you can extract or make inquiry to the raster data and import it in a table format. So you can analyze them in your own analysis platform or the database that you are already using. So that kind of physical climate risks can be applied to infrastructure project or any other development project. And most recently, we provided wildfire risks to our transportation sector. In this case, they were interested in the wildfire risks along the railway. And again, this is where applied science really become important, because the wildfire risks in the forest are very different from wildfire risks in the crop areas or residential areas. So we really consider the users and the reasons for them to use these data, and we change the format as well as the how we are deriving the information. So if any takeaway message, we really focus on applied science, and we are powered by cloud computing, and we are Google Cloud partner. I'm happy to chat with any of you who are interested in, because this is not an exhaustive list of products or work that we do. So yeah, let me know if
is global